Hey, welcome back. Today I'm going to be going over this SAT geometry question. And once again, thanks to anigo.ai for providing this specific question in the free resources tab. But before I dive into the explanation, please give this a try yourself. Okay, so here we have triangle ABC where angle B is a right angle. So I'm going to be drawing a diagram as we read the problem. So we have angle B, that's the right angle. Point D lies on AC, okay, such that BD is an altitude to AC. So point D lies on AC such that BD is an altitude. So BD is an altitude there. If BD equals 120, so I'm going to write 120 there, and sine of A equals 12 over 13, which choice is the length of DC? So we're trying to find the length of DC. I'll kind of highlight that in blue. And sine of A is 12 over 13. So, with all that given information, right, what do we do first? Well, first of all, right, recognize that sine, right, if you think back to SOHCAHTOA, if you know what that abbreviation is, right, it's opposite over hypotenuse. Right. So it means that 12 over 13, well, that's going to be opposite over hypotenuse, right? So we're going to call this 12, and we're going to call this 13. Now, here's the key thing to realize, right? This doesn't have to be 12, right? It could be, and actually I'll do some testing here just to kind of show you the point. It could also be 24, right, over 26, right? Likewise, right, this could also be 36 over 39, right? Because that ratio, 36 to 39, is always 12 over 13, right? So what's my point of showing you that? Well, because we're not going to call this 12 and 13, we're going to call this 12x and 13x. The reason is, well, if you put an x here, right, they're going to cancel out anyway, right? That x just represents a scale factor, right? But this ratio 12 over 13 stays constant. So we're going to call this 12x and 13x. Okay, so now this is essentially all the given information we have, and once again, we're trying to find DC. So how do we do this? Well, there's a couple of things you have to kind of know coming into this question. But first of all, let's find what AB is, right? Because this is a right triangle. Well, this is 13x, and this is 12x. You can use the Pythagorean Theorem, but I also have the triple memorized, right? This is going to be 5x, right? And if you want to check, right, if you do a squared plus b squared, right, you'll realize that equals 169x squared, which is the same thing as 13x squared. So we found that. Now, this is where you have to know a couple of, well, you have to know a specific formula about this diagram, right, where you have these two right angles. You have the bigger one, and then you have a one inside it, which is that a leg squared, so in this case, let's go with 5, and I'll use a color red here. So a leg squared, so that's 5x squared, equals the closer segment times the entire segment. I'm going to call this A, and I'm just going to call this B. But it's the leg squared equals the closer segment, so that's A, right, times the entire segment, right, which is 13x. If you simplify this, this is 25x squared equals 13x times A, right? So you get 25x over 13 equals A. So that's your length of A. What about B? Well, same logic, right? B is going to be your leg squared, right? You'll notice that when I say leg, I'm talking about the leg that's closer to the side we're trying to figure out. So in this case, 12x squared equals the closer segment, so that's B, times the entire segment, so that's 13x. And once again, if you solve this, you get 144x squared equals 13x times b, and of course b equals 144x over 13. So now that we have solved for both of those segments in terms of x, what do we do? Well, earlier in the problem, we're given that this is 120, right? And this is where that second formula comes in, right? Which is, if you have an altitude, right? The altitude squared, I'm going to use purple here, the altitude squared, so 120 squared equals this segment times this segment. So it equals a times b, right? So, once again, 120 squared, which is the altitude squared, equals a times b. What does that equal? Well, 120 squared equals a. We found a was 25x over 13. We're going to use one color here just to be consistent. So you have 120 squared equals 25x over 13 times b, which was 144x over 13. Now, you could use a calculator for this, but I'll show you how I kind of did this. So if you multiply the fractions here, on the bottom you get 13 squared. On the top, you have 25, which is 5 squared, 144, which is 12 squared, and then the x times x is x squared, right? So then you'll realize that 120 squared equals 5 times 12 times x, which is, so again, 5 times 12 times x, because you can take the squared out, right? You see that each of them have a squared term, over 13 squared. Since the squareds here are equal, well, the insides here have to be equal, so you have 120 equals 5 times 12 times x over 13. 120 equals 60 x over 13, right? 120 times 13 over 60 equals x. These cancel out. You get x equals 26. So now we have x equals 26, right? Now, what are we trying to find? We're trying to find the value of dc, right? The length of dc. Well, dc is just b, right? If you go back to what b was, well, it's 144 times x divided by 13, right? Well, we found x, so it's 144 times 26 over 13. These cancel out. You get 144 times 2, which is 288. And that gets us to answer choice C. So, the key thing to realize about this problem is just formulas, right? If you ever have a diagram where you have one big right triangle and then an altitude, right, that makes two other ones, then you can always use these formulas, right? So remember, right, it's your legs squared equals the closer segment times the entire, right? Your legs squared equals your closer times the entire. And then your second formula is that your altitude squared equals this segment times this segment, right? And on the SAT, it's not always going to be this specific orientation. What I mean by that is like sometimes you might have a right triangle like this and the altitude here, right? But once again, use the same logic, right? This is A, let's call this B, let's call this C, let's call this D, let's call this E, right? Oh, let's call this X. So once again, right, same logic, leg squared equals your closer, so that's B, times the entire thing, right? So times B plus C. Same thing with D, right? Your D squared, which is your leg squared, equals the closer, C times the entire thing. And then the altitude, right, squared equals B times C. These are the really three important formulas that will definitely help you save time on the SAT. But After you do that, right, it's just a bunch of algebraic manipulation and solving, which should give you the right answer. So I hope this made sense. If it didn't, please leave any questions you have down in the comments. But once again, thanks for watching, and I'll see you next time.